everybody. Hi, I'm Jesse. How many of you use a keyboard? Okay, almost every hand went up. That's good, because I bet you all use keyboards. If you've seen me at OSDC in previous years, you probably used to see me with a big Microsoft keyboard that I would keep in my bag, because my hands are very bad. And so I've always had a keyboard I carry with me. But for many years, it was cheap keyboard, costs maybe 300 Taiwan dollars. And then about 2 years ago, I discovered that there are keyboard otaku, people who love keyboards and make interesting keyboards, and that you can spend lots and lots and lots of money on keyboards. So one important thing to know is, as an American, I use lots of crazy idioms, and I talk very fast. So if I'm not making sense, wave your arms or say, "Hey, Jesse," anything, just to remind me to go slow, because if you don't understand me, probably nobody understands me. That's good. So building keyboards. The first question that I tend to get asked is, why would you make a keyboard? The answer is that, well, my keyboard kind of got taken over, the one I was using. But these are things that can be dealt with. The more honest answer is that I tried a lot of keyboards. In the US, there's a saying that you spend a lot of your time sitting in your office chair or lying in your bed. And so it makes a lot of sense to spend a lot of money and get a very good mattress in your bed or a very good office chair, because for the dollars per hour, it ends up being really cheap. As a programmer, I type a lot. So it turns out that even if I buy a really expensive keyboard, if it makes my hands hurt less or it makes me able to type faster, it's worth it. It's always worth it. And so I started looking around at keyboards. I went and tried pretty much everything. I tried the really simple stuff. Let me see if this little thingy works. Pointery stuff. You know, really basic keyboards, old IBM keyboards, that can split in half, crazy Japanese keyboards, crazy British keyboards, crazy keyboards, where each finger basically has a D-pad. This one is a keyboard from, before the iPhone came out. The way I know that is the company vanished one day. That was the Fingerworks Touchstream. The company just one day went gone. Nobody knew why, just out of business. Then 2 years later, the iPhone came out. There are touchpads inside. That's the iPhone keyboard in the early beta version. So anyway, I tried everything, and no keyboard really made me happy. So I sort of went on this crazy journey, learning how to make keyboards. Has anybody here ever done any soldering? Even a little bit. Connect, two wires with a bit of solder. Okay. So I had not since I was maybe 9 years old. I knew nothing of soldering. But I started looking at the keyboard otaku forums, and there were people making keyboards and had the obvious scary Perl hacker. How hard could it be? Turns out, not very hard. So if you want to make a keyboard, there's some things you need. First, let's talk about tools. You will need a soldering iron. You will need a way to make connections between wires. Soldering iron is probably what you will use. You need a wire cutter. You don't need a fancy wire cutter. Nail clipper is a fine wire cutter for what we're doing here. Fancy wire cutter makes it a little easier, but don't bother buying one. You don't need it. Now, there are tools you don't need. Those are all the tools you need. There are tools you want. There are things that will help make it a little better. A better wire cutter. That helps. Solder sucker. So when you solder things, you basically touch your one wire to a board or to another wire, and then you drip a little bit of solder on it. And if you're new, if you don't know how to do it very well, you make a lot of mistakes. So what that is it's like a little vacuum for solder. So when you make a mistake, you hold it on top and hit the button, and it says, and takes all the solder away. Makes your life so much better, not very expensive. And it turns out that holding tiny little wires next to each other and then applying a very, very hot soldering iron to them makes them hot. So it's better to have tweezers to hold your wires in place so you don't burn your fingers. If you're really careful, you don't need them, though, if you're trying to be cheap as possible. So, and then there's this one. This is probably the last thing I bought during my experiments. It's a multimeter. The idea behind a multimeter is it can diagnose all kinds of electrical problems. But it has one setting. The one setting is pretty much all I ever use. This one. That makes a beep sound when this wire touches, or when this connector touches this connector, which lets you tell if you've done your soldering right or wrong. So this is all very, very basic intro electronics stuff. If you know anything about electronics, you're probably sitting here laughing at me. This is stuff that a first-year student would learn. I'm a software guy. I didn't learn any of this stuff. So I had to figure it out by reading how-tos on the internet. And then there's this, a hot glue gun. What's the Chinese for hot glue gun? Anybody? Okay, people know what I'm talking about. So the basic idea behind this is it has these sticks of glue. It gets them hot. It melts. And then as the glue cools, it holds things in place. Things like wires, things like plastic you broke, things like your fingers. But if you get it hot again, you can get it off, which is better than, say, using real glue, super glue. So now let's talk about the parts for your keyboard. Key switches. These are the things where you press it down and it makes an electrical connection. So these are Cherry brand key switches. These are Cherry key switches come in a bunch of different colors. So the blue ones are the clicky sounding ones. The brown ones, the ones with brown stems, feel like they click, but there's no clicking noise. The red ones, they don't have any sort of clicky feeling, and they're soft and easy to press. The black ones are harder to press, and then there are 8 more colors. But the ones you usually see are blue and brown and red and black. There are other kinds of key switches that are less expensive, but generally considered less good. I literally could spend my entire half hour just talking about key switches, but it's kind of boring and not worthwhile. So you need key switches to make a keyboard. Otherwise, you'd be sitting there just touching one wire to another wire. You need diodes. I'll talk about why later, but these are the kind of diodes you need. You need basically one for every key switch. You need some wire to connect things up together. Magnet wire is simple and easy to use. It's very thin wire, and its coating is made of enamel, which means that you can either scrape the coating off, or you can use the soldering iron to heat it and burn the insulation off. This makes it a lot easier to work with for lots of little fine connections than using big stiff wire. And I didn't learn this for the first 3 months. So this is something that easy tip to learn now. You need solder to be able to solder things together. Solder is usually made out of tin with a little bit of lead. There is newer solder that is ROHS, R-O-H-S, that has less bad for you things in it. The solder that has less bad for you things in it is harder to work with. Solder traditionally has what's called flux in the middle. Flux is what makes the solder melt and what makes it flow. And so traditional solder has rosin, basically from tree sap, inside that makes it flow, makes it easy to work with. For the keyboards I'm talking about, you need a microcontroller. So the one I've been using is an Atmel AT-Mega, and the brand I've been using is the Teensy. So in the US, it comes from pjrc.com. There are lots of people who make the exact same chip in a similar housing. You could use an Arduino Micro. You just need something that is a microcontroller. Or, as I found out from a Taiwanese keyboard designer yesterday, you can just use an ARM CPU, because ARM CPUs are now cheap enough that people use them instead of 8-bit microcontrollers. But so anyway, this thing has all kinds of functionality on it, but what we care about is that it has a USB port, a reset button, and then a bunch of a bunch of analog lines. You'll see how that gets used in a little bit. You, of course, need keycaps, the things that stick on top of your keys so you can press them. The easiest thing to do is, if for making your first keyboard, is to just steal them from an old keyboard. You can also buy them in sets or in large quantities, but these actually were just stolen off of an old keyboard. These were purchased in quantity, like I think I bought 1,000 of them because I started realizing that I didn't have a lot of old keyboards. And you need a case. You need a case for your keyboard. That's pretty much all you need. So things you might want to have: jumper wires, and I'll show you how I use them, make it easier to build things with less soldering. And you probably want to have a cable to be able to hook your keyboard up to a computer. But that's it. Don't need anything else. So I mentioned the case and how to make, so the case is sort of the place where people can do interesting things, where you can make something that is yours. So the first cases I made, well, the only things that you need to care about are the size of the holes and how far apart they are. So the holes that each key go into need to be 14 millimeters square. They can't be 13.9. They can't be 14.1. They just need to be about 14 millimeters and square. And then your plate needs to be, this is 1.5 millimeters thick. They need to be 3 millimeters apart so that the keycaps don't stick together. Keycaps are designed to be about 3 millimeters wider than the keys. So while the top plate should be 1.5 millimeters thick, the bottom plate and the sides can be much thicker. So the reason you want the top plate to be that thin is that each key has tiny little clips on the side. So when you push it in, it grabs the side of the plate, and that assumes 1.5 millimeters thick. So then the keys don't move. And again, I didn't learn this the first time around, and you'll see pictures of the crazy shit I had to do to make it work. So I've always figured I would need to learn expensive CAD software to be able to design keyboards. People know OmniGraffle? It's kind of like Visio, but for the Mac. It's 2D CAD software, or sorry, 2D drawing software. You could use Microsoft Paint. But so my first keyboards I literally designed in OmniGraffle by making a 14 millimeter hole, making lots of copies of it, putting them in places, and making sure that they were 3 millimeters apart. And that was it. I drew holes for where screw holes go, and I drew the outside boundary. And then I printed these things out so I could touch them, but I just printed them on a laser printer so I could get a feel for whether my fingers were in the right place or the wrong place. And then I would walk around to coworkers and say, "Does this feel good to you? Does this feel good to you?" And I'd watch as they tried to type to see if I'd gotten their fingers, if their fingers could reach where my fingers can reach. If I were a real scientist, I would have rigged up a webcam overhead and run them through typing software and analyzed how far their fingers could go, but no, I just kind of watched them. So after I prototyped with paper, this picture is awful and I'm really sorry, but it's the only one I have. In Boston, there is a laser cutting store. You can walk in and they will use a laser cutter to either cut things out of plastic or wood for you or draw pictures on your MacBook. They just charge you $2 a minute to use a laser cutter. And so I went in and they cut me out. You can just see the edge, the top plate here. I'm really sorry for the bad picture, but you can see my 14 millimeter holes in the top plate. And then you can see the edges of the sides. But that was just cut out of designs I did in OmniGraffle. If you've got really interesting ideas, 3D printers can work. So this is a keyboard I built using that laser cutting technology. I went and designed it. I designed it the day before Valentine's Day. And so that's why it has the nice red heart. I gave my wife the heart from the inside. But this, all designed by hand, or designed in OmniGraffle, cut in a laser cutter, and within 8 hours from came up with the idea to a full done keyboard. My first keyboard took, I think, 40 hours of soldering because I didn't know what I was doing. But I'm going to pass this around and so people can look at it. Later, I can set it up so people can actually type on it with a computer. But so diodes. Why do you need to solder a diode to every key in your keyboard? Do people know, if I say key ghosting, does that mean anything to people? Are there gamers in the room? Huh, okay. So the idea behind key ghosting is this. So this is a keyboard. This is the schematic for a keyboard. So there's a key here, there's a key here, there's a key here, there's a key here. All of these are keys. And these are your rows, these are your columns. So pretend that's a keyboard. This is the schematic for a keyboard. When you press a key, what happens is that electricity is flowing down the row, getting to every key, trying to look for a way to get out. And the only place it gets out is where you've actually completed the circuit, where you've pressed down the key. The way these key switches work is they actually make a mechanical connection, and then electricity flows. So that's fine. For one key, that's fine. For another key, that's fine. Now you press two keys at once. And what happens is the electricity can flow places you didn't mean it to, because it can flow backwards. And so what diodes do is a diode says electricity can only go in one direction. And so by putting a diode on each key, it means that the electricity can't short across other things and flow through keys you don't mean it to. If you have a really cheap keyboard or an old keyboard, if you hit W and A at the same time, sometimes you'll see a Q or an S because you've connected both those places. You can prevent this in software. There's software for anti-ghosting. And what that says is, oh, Jesse pressed W and A at the same time. So there's no way he could be pressing Q or S. So don't show a Q or an S. But if I hit W, A, and S at the same time, that's not so awesome because it will automatically suppress it. So diodes are the magic that makes it so you can hit more than one key at once. So actual keyboard assembly. The first thing you should do is take all of your keycaps and all of your keys and stick them into your key shell. See how it feels. See if you got the holes the right size. See if things are far enough apart. Make sure that keys don't stick when you press them. And if that goes well, then you can continue. If it doesn't go well, you may have to go and recut your plastic plate. So this is where you pull out your soldering iron and you start soldering. And each key, if you look at the bottom, it has two pins coming out. One of them is square, one of them is flat. In general, it is easier to connect the diode to the flat pin if you're doing hand soldering. That's just because it's more surface area and it's easier to make a connection that way. So generally the diodes go in the column, well, I'll get there. Diodes go in columns and the straight wires go on the rows. So this is another keyboard design. Oh, we'll get there. So you connect the keys in each row. So then you solder the diodes in columns. Diodes should get wired in parallel. What that means is that each diode should connect to the same wire that runs all the way up. It's not that you should connect this diode to this diode to this diode. They should be in parallel, not in series. And when you wire up your diodes, the black side goes near the key. Like I said, remember I said that diodes only allow electricity to flow in one direction. If you wire them backwards, you can never press a key. My first keyboard, I wired it all the way up and then realized I'd wired them backwards. This is not an example of good solder technique. This is an example of my first soldering. But so after you wire up the rows and the columns, then you need to solder a connection from each row and from each column back to your controller. So I said that you might want to use jumper wire for this because jumper wire makes it really easy to connect to the pins on your microcontroller. So on the one end, you've got your microcontroller with its pins and the ends of the jumper cables. And on the other end, you've soldered them to your rows and to your columns. Now you're done with all your hardware. That's a keyboard. On the software side, you need to install GCC. So there's a nice open port of GCC, AVR GCC. It's free. It's designed for the microcontrollers we're using. I'm going to pass around another keyboard starting from this end for people to play with. So this is a 3D printed design that I'll talk about at the very end. You install GCC, and then for the microcontroller I'm using, there's a nice little graphical program, the Teensy Loader, that will let you install the stuff you build. For pretty much any microcontroller, there's some program that will do the loading. So sometimes it's a command line tool, sometimes it's graphical. There's Teensy Loader for Linux and Mac and Windows. Then you need some keyboard firmware. You need to actually tell the microcontroller how to do things. Because we live in the future, there are a bunch of pre-written, high-quality, open-source keyboard firmwares. The one I like is this one. And so my keyboards are running open-source firmware. You can, it's GPL'd. You can know that there's no keylogger in there because you can compile it all yourself. Or if you want to, you can add a keylogger. So the way you configure this thing is you edit the KSpec file, the keyboard specification. The important parts of the keyboard specification are thus. Where you connected the wires for each column, which pin on that controller, and where you connected the wires for each row, which pin on the controller. Then you need to describe which key is in what position. So the 1 is the first key, and then the 2 is the next key. There's a whole language for doing function layers and shift and multiple layers and crazy things like that. But for the most part, this is all you need to do. Then you save that file. Then you type make. Make does that. It builds some stuff. It builds a binary. And then you use your Teensy Loader. The way you do it is you hit that little button on the controller. If you're looking at the heart-shaped keyboard, you can see that button, and it's fairly easy to get at. If you're looking at the purple keyboard, you can actually look into the hole on the purple side, and you can see the button. If you're really advanced, you can actually write code so that you hold in magic keys, and it will do it automatically, but this is easy enough. Then you click this button to load your firmware from disk, this button to program it, this button to restart your keyboard, and congratulations, you're done. You have a working keyboard. Well, except for the things that don't work. Hardware, it turns out, is like software. You do have to debug it. Debugging hardware is a little bit more annoying. Patching hardware is a lot more annoying, but it is much more satisfying. It feels really good when you patch hardware and it works. The way to test the keyboard is you hit a key, and if it doesn't register, you figure out whether it's a bad solder joint or what. The easiest way to do that is to use the multimeter. And you put the probe on one side and the other, and you hit a key, and you see if it beeps. So things I didn't mention when talking about building a keyboard. I did not mention a circuit board. How many of you have designed a PCB? Yeah, I haven't either. I don't know how. Friends of mine who do electrical engineering say, you solder by hand? That's stupid and hard. It's much easier to design a PCB, have a company make it for you, and use it. I don't know how to design PCBs. So if you know how to design PCBs and you have a fab, let them do it. That's great. But you don't need to. This would take time. It would take another skill I don't have yet. If you're going to make 50 of them or 100 of them, you want to do this, because it's a lot of soldering by hand. But if you're going to make one keyboard to use yourself, you don't need it. If you're going to make 2 keyboards for friends, you don't need it. If every keyboard you make will be a little different as you learn what you want, you don't need it. You don't need it. So far, I have made 6 keyboards. The first one was a design somebody else made, and I have 5 minutes left, so I will talk quick. The Mark I was a design from ergodocs.org. They came up with this cool thing. I really wanted it, but they only put the designs for the shell online as 3D files. So I downloaded the 3D files and sent them to a company to have them printed. That cost $250 US, kind of expensive. But they didn't release their PCB, and I wanted to make the keyboard. And so eventually I just gave up and decided to wire it by hand. I stuck the keys in, I wired up the rows and columns. One of the mistakes I did here was that I used big, heavy wire to wire things up, which is what I read on the internet somebody else did. And when you use big, heavy wire, even a tiny little bit of things moving around will crack your solder joints because there's no flexibility. I also soldered the diodes directly to each other. Has the same problem. Also, I wired the diodes in rows and the straight wires in columns, which is fine, but none of the firmware expects it. So I had to hack the firmware to make it work. My solder technique was really bad. You can see I melted lots of keys as I learned. Then I hooked up some prototyping wire, and I made a ribbon cable to connect the two halves of the keyboard. And I shoved the teensy in the corner, and more bad soldering. And because there were going to be short circuits, because I had a wire right on top of another wire, I put tape in places. Total hack. Really bad job, but it worked. The next keyboard I designed from scratch by myself. This one I designed in OmniGraffle. And I came up with a basic layout I wanted. And then I moved the keys around a little bit to be closer to how hands fit. And then I sent it to a local shop that has a laser cutter. And they cut it out of a piece of plastic. And I shoved my keys in and realized that my keys didn't fit very well. So I used super glue around the edge of each key, which kind of works, but it makes the plastic look ugly. And when super glue gets inside your keys, they get scratchy. They get just not comfortable to press. But I put keys on the front, and I played with it, and it felt nice, so I started wiring it up. I wired diodes. I did crazy, crazy things to make sure there weren't short circuits. I put electrical tape over every connection. I taped my microcontroller in place. I used an old ribbon cable to connect things rather than my prototyping wire. And then I bought a picture frame at an art store so that I had something to hold the keyboard in. I just went in and said, I want a picture frame of this size. And it was awful, but it worked. The next keyboard was a more traditional design. This is when I went to learn to use the laser cutter. So they told me they wanted me to do it out of wood rather than plastic, since the wood was cheaper. But same thing, stuck the keys in, wired up the rows. You see here I'm using thinner wire. One of the things I started doing is if you leave a little bit of a space between each key, there will be less stress on the wire, so your connections won't break as easily. So I wasn't good about it, but I was getting better about it as I went down the keyboard. Then again, bad diode technique, just wired diode to diode to diode to diode. And then, of course, I gave it a serial number and signed it. And it worked. Didn't like it very much, but it worked. The next keyboard design was actually based on a Japanese design from the 1980s called the Tron keyboard. I actually got a copy of their paper book explaining, their paper conference presentations explaining the angles of everything, because the book was $20 US and the digital copy of the paper was $80 US. Printed out of mostly clear plastic. You can see it a little better there. I put the keys in to see what it felt like. Wired it up. This time I actually did something a little different with the diodes. I cut the ends of each diode very short, soldered the diode to the key, and then used wire to go between diodes, which feels like basically works a little better, is a little easier to wire, is a little more robust. Drop my microcontroller in the middle, working keyboard. The next keyboard, I found out that the angles from that last keyboard that were designed for guys from Japan in the 1980s, turns out that they have smaller hands than me, and their shoulders are not as wide as mine. So this was updated angles for big Americans. And I've been typing on this one for 6 weeks and really like it. So I actually went and laser cut it myself, which was pretty cool. I got to watch the machine cut out each key. Ended up like that. When you pick it up, the keys are left. Wired it up, dropped my microcontroller in, and then I used Sugru, basically silicone plastic, to shape the keys that didn't fit very comfortably to be closer to my hand shape. The most recent keyboard I made, the new one, I finished this one on Monday, and I'm going to run a minute over, I'm very sorry. I actually 3D printed it home. So I did a whole bunch of tests to figure out how to make the keyholes the right size. I tried to print the entire keyboard in one go. That didn't work. I tried to print a pretty bottom. That didn't work. The first few times I tried to print each hand piece, it bubbled. A lot of this was learning how 3D printers work. So these were all the experiments I did leading up to having a working keyboard. So this was the sort of first one hand from that. This was the first attempt at a shell, and my keyboard plate was a little too wide for the shell. So only about 3 millimeters too wide, but still too wide. Tried both hands, eventually got something that worked, wired it up much like the previous ones, using prototyping wire to go between the halves, using that very thin wire to connect from diode to diode and key to key. And then on the other side, the same. Connected everything to the microcontroller. One useful tip is when you do this, take pictures of the wires so that when you open it up, you know where the red wire is supposed to go on each side. So you don't have to remember what thing is on pin C2. You can see that it's a black wire. Wired it up together, and that's the keyboard I ended up with. Sorry, I ran a bit over. Thank you. Questions? Yeah.
There are some red things that stick out from the keyboards that fits your finger, right, better.
Uh-huh.
How did you make them? And I mean, were they?
So
Was your hand there when it was shaped?
So that's called Sugru. It's basically silicone putty that dries in air over 24 hours. So I put it on the key, and then I put my finger down and basically just made it comfortably shaped. Yeah.
How many hours do you think the first time keyboard builder to build it?
So how many hours does it take for a first-time keyboard builder to build a keyboard? My first one, and I didn't know how to solder, took me about 40 hours. But it would have been half that if I had a good tutorial to read. I didn't know, which way the diodes go or that they're supposed to go in parallel. It probably would have been about 20 hours the first time if I knew a little more about what I was doing. Yes? How do I decide the position of the characters on the keyboard? So, as in the position of which letter or which physical key, or where I put the black keys? Oh, right. So my basic idea is based on your pinky fingers, the little ones. They're not very strong. They're very weak. Most hackers I know hit shift with this key, or with this finger. And so if you look at my keyboard, your pinky fingers have very little work to do. I move most of this work to your thumbs and to your index fingers. And so some of this is from Japanese research from the 1980s. Some of this is just me thinking. I have a long story about why keys are on your pinkies. It's a lazy engineer from 130 years ago who didn't want to do a second rev of his design. That's why all of those keys are on your pinky fingers. Next question? Yeah.
Have you ever tried or will you try to make wireless keyboards
Have I ever tried or will I try to make wireless keyboards? I made a Bluetooth to USB adapter. So you can plug it into your USB keyboard and it becomes Bluetooth keyboard. But it was just a first test version. It only worked for 5 minutes, and then you need to repair the device. You can actually get pretty cheap Bluetooth stuff these days. It's not very hard to do. It's just one more thing that I haven't spent a lot of time on yet. Any other questions? Okay, thank you all so very much. I'm happy to answer more questions up here, but I know it's the end of the day, and so people should feel free to get out of here. Thank you. And yeah, if I could have my keyboards back.